Hey everybody, here is the video for subtracting mixed numbers. You're doing so well with adding and subtracting fractions, but yes, there's a little step up here. So please keep up with the good work, keep listening, keep taking notes, keep watching videos and practicing, and it's gonna help you with this lesson. Okay, so before I start subtracting mixed numbers, before I talk about this, I want to talk to you about what we already know about subtracting. So for example, if I have 124 and I want to take away 37, just an example. Okay, we're not talking about fractions here, but it's just subtraction that I want to talk about. We know that if I have 4, I cannot take away 7. I don't have enough ones here to take away 7. I have only 4. So we know to regroup. So we take 1 from here. So this turns into 1. And that 1, we put it over here, right? So I'm taking away 1. We always borrow 1 from the neighbor, right? We always borrow 1. Well, when it comes to fraction, I want you to think about it, okay? I'm talking about fractions. So I can't just use the number 1 in this case. So yes, we always borrow 1. 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 You maybe wonder why I did this. But what I want you to see is how can I rewrite these as fractions? Because again, when I'm subtracting fractions, I cannot add this one when I regroup to that fraction. I have to add as a fraction. So you need to know that when I take away 1 from the neighbor, when I borrow 1 from that neighbor, that 1 has to be written as a fraction. So, for example, 2 halves is the same as 1. 3/3 is the same as 1. 4/4 is the same as 1. 6/6 the same as 1. 5/5 is the same as 1. 8/8 is the same as 1. I can continue. 12/12 is the same as 1. 10/10 is the same as 1. I can do that. Okay, so what I want you to take away from this part of the lesson is that whenever I have to go to my neighbor and borrow 1, that 1 has to be written as a fraction. Okay, and how do we know which one you're going to use? It depends on what fraction you're talking about, what you're using to subtract. So I'm going to go and show you an example. I'm going to do the whole thing, and I want you to watch and see um, what it means to subtract. Okay, so I'm going to put an example 12 and 3/4 take away 11 and 7/8. We all know this part you are good with. Okay, you know that you can't subtract these two because my denominators, the 4 and the 8, are not the same. So I have to find a common denominator for these two, and I list my multiples. So for 8, I don't need to go on because I already found a common multiple here that works as my common denominator. So what I like to do, neatly take your time, okay, is copy everything with your new denominator. So I'm going to copy 12, and here I'm going to put my new denominator, minus 11, and here I'm going to put my new denominator. You notice I left my numerators blank, and why is that? Because I like to focus on one thing at a time, okay? Because now I'm going to go and see what I changed. This one, the denominator was 8 and it stayed the same. So my numerator is staying the same. I'm not doing anything to it. Now here my 4 did change. So my numerator is going to have to be different. It's going to have to change. Because what I'm doing, I'm creating equivalent fractions. And how do I find equivalent fractions? I can multiply both by the same number and it will give me an equivalent fraction. So what did I do to 4 to get to 8? 4 times 2. So here I have to do times 2. So slowly go back. 3 times 2 equals 6. Make sure you check this. It's not 3. It's 3 times 2. Now you have your answer here. When you look over here, you have 6/8 and you have to take 7/8. You have 6/8 and you need to take 7/8. That's not enough. I don't have enough here. That's when it comes to the next thing. You have to borrow from your 12. Well, you do the same thing. You borrow what? 1, right? So this is not 12 anymore. It's 11. What happens to that 1? Remember, I told you you have to regroup it as a fraction. Now, if you noticed, my denominator is 8, right? So I'm talking about 8/8. So my whole, instead of 1, that 1 from here goes here as 8/8 because I'm talking about eighths. So again, this 8/8 is the 1 I borrowed from my 12. So 12 is now 11, and that 1 is my 8/8. Now, because they are the same here, look at this. How many eighths do I have now? Well, 6/8 plus the 8/8 that I added here, I actually have 14/8. Oh, now 14/8 is enough to take away those 7/8. So 14/8 take away 7/8 equals 7/8. Then you go back here, 11, take away 11 equals 0. I don't need to put it over here. So my answer is 7/8. That's your final answer. 11 take away 11 is 0. So your final answer is 7/8. Okay, so check this. Okay, practice taking away 1. What fraction am I talking about? I'm talking about eighths. So you add 8/8. I'm going to do a second one. You may start hearing this missile noise, so bear in there with me, okay? And watch this as many times as you need. So let me go to another problem. So the next one I'm going to do is 8 and 1/4 minus 2 and 5/12. Again, forget about the whole number for now. The whole numbers, right? Look at the fractions. You know how to subtract fractions. You can't. They're not the same denominator. So I need to find common multiple between 4 and 12. Between 4 and 12. So 4, 8, 12. Oh, I don't need to continue. I already found my answer. Okay, so what is the next step? I write everything with my new denominator. Subtract 2 and with my new denominator. Again, my numerators are blank because I'm going to go check on them now. I fixed my denominator. I'm good. Now I'm going to check my numerator. 12, 12. Did not change. 5, 5. It does not change it. Then here, 4, it did change to 12, right? So 4 times, I have to do the same thing here. 4 times what equals 12 is 4 times 3. So you have to do that 3 at the top too. So 4 times 3 equals 12. 1 times 3 equals 3. Now we got to our problem. How many 12ths do you have? How many 12ths do you have? We are talking about 12ths. You know you're going to have to borrow because 3/12 is not enough to take away 5. So I have to borrow, but remember we are talking about 12ths. I don't have enough 12ths to subtract, so I need more 12ths. Okay, so what do? I borrow 1 from here. So this is now 7. Sorry about that. I'm going to try to finish this. Give me just 1 second. So here it was 8. Now I have 7. That one that I borrowed goes here as what? 12. 12. We know 12. 12 is the same as 1. And why am I using 12? Because I have 3/12 to take away 5/12. And 3/12 is not enough. Now do I have enough 12? I have 12/12 and 3/12. I actually have 15/12 now. 12 plus 3 equals 15/12. That's enough to take away 5/12. So 15/12 take away 5/12 equals 15 take away 5 is 10. 10, 12. 7 take away 2 equals 5. Now, for now, I will accept this as an answer, but you have to start thinking about reducing this. These two numbers are even. How do we reduce it? We start dividing by 2 until we can't anymore as one of the strategies. So if I actually do this, when you divide by 2, because both are even, you are basically cutting it in half. Okay, so if I divide this by 2, 10 divided by 2 equals 5. 12 divided by 2 equals 6. Or half of 10 is 5, half of 12 is 6. And this 5, you just continues here. What does that mean? These two are equivalent. I just reduced the 10, 12 because these two can be reduced. Okay, for now, I will still accept this. Sounds good? All right, so I need you to watch this as many times as you need. Pause, watch it again, especially go back if you need to see what's happening here. Okay, and don't forget that I'm always borrowing one. We always borrow one, right? But that one has to be written as a fraction. So it could be 5/5, 6/6, 10/10. It depends on what you're talking about. Okay, so we'll be working more with it tomorrow. Okay, bye.